Ladies and gentlemen, welcome to our physics revision class, and in this particular class I'll be solving 2023 physics 1010 exam paper, and this paper was prepared by the University of Zambia, specifically the School of Natural Sciences and Physics department. So please make sure that you ask questions and feel free to participate. So let's quickly look at the solution, and of course I'm not solving the whole of the paper, but in this particular tutorial I'll just solve question 2a. So question 2a says a vector A has a magnitude of 30 meters at an angle of 200 with respect to the positive x-axis. So I'll write my solution, and it's very important for me to collect the data. So from the information that I've been given there, I'll start with the data collection. So I have my y-axis and I also have my x-axis. Okay, so from the information that has been stated there, I have been told that there is a vector A, and this vector A has a magnitude of 30 meters. Okay, has a magnitude of 30 meters. So magnitude simply means that the size of the vector. And then the other thing is for me to know the angle. Okay, the angle is 200. So 200, if this is 90 degrees, okay, that one is 180. Then this is 270 degrees. The other one is 300 degrees, 360 degrees, sorry, this is 360 degrees. Then that simply means that vector A is in the third quadrant. Okay, so this is the vector A, and vector A is having the magnitude of 30 meters. Okay, and for the angle of vector A, when you talk of the angle of vector A, it is 200 degrees. So 200 degrees from the positive x-axis. So this is 200 degrees, which is simply the direction. Then we have been told if we add a vector B, it is found that the resultant is along the positive x-axis and has a magnitude of 10 meters. What are the components of vector B? So this is another point which you have to understand. So this one will need some understanding, some English understanding here. So I'm going to plug in my resultant vector. Okay, vector B, I don't know it, but I have my resultant vector R with magnitude 10, of which it is along the positive x-axis, So this is where people got it wrong. So along the positive x-axis simply means that it is just simply lying there. So this is how this vector is looking like. So it is like that. Okay, so this is the resultant vector R, and this resultant vector R, it is lying along the x-axis. So I'll put my 20, is it 10 meters? So I'll put my 10 meters there. Okay, so after I have this information, remember there is addition. There is the word addition of vector B, So with this information I have, I can easily now look for the components. Okay, the next thing I need to look for is the component. After having this, I need to look for the components of these vectors. So this is the resultant arrow. So I'll start with vector A. Okay, I'll start with components of vector A, components of vector A. So let's quickly look at the components of vector A. I'll start with the x component. I'll start with the x component. Okay, I'll start with the x component. So if you look at the x component of vector A, which you can just simply say ax is simply equal to vector A cos what? Cos theta, according to what we discussed from our lecture class. So for those people who are new, please make sure that you watch our class. Make sure that you watch our class on this component vector. So ax will simply be equal to, what is the value of vector A? It is 30. Okay, and then you're going to say cos, what is the angle, which is simply 200 Newton. So ax will simply be equal to 30 cos 200. It is 28.19078, of which this is a negative. Can someone confirm with me if my calculation are okay? What are you having on your side? Is it the same value? Sorry?
Yes, it's negative 28. Yes, negative 28.90.
All right. Okay. Okay, thank you very much for that. So with us knowing the x component, we can now quickly look at the y component. We can now look at the y component of this vector. So the y component, you are going to say ay is simply equal to a sine theta, a sine theta. So ay will simply be equal to 30 sine 200, 30 sine 200. So 30 sine 200, 30 sine 200, your answer will be negative 10 points. Ay, the answer will simply be negative 10.2626060. Okay, so this is the what? These are the component of this particular vector, and be much careful to put the units meter there and also meter there, because there are some lecturers or professors who are very strict. After I look for the component of A, I can now look for the components. I can now look for the components of the vector R. Okay, I can now look for the component of vector R, which is just the resultant. So from here, if you look at vector R, it is along the what? It is along the x-axis. So no need of stressing. Then cos is 0. So here you're going to say Rx simply equal to, you're going to say R cos theta. That's the x component, and this will be Rx simply equal to the magnitude is 10 and then cos 0, because it's along the x-axis. So if you say cos 0, it is 1. So Rx will simply be 10 meters. It will simply be 10 meters. With the finding of Rx, I can quickly find Ry. I can simply find Ry, which is simply equal to R sine theta, and then Ry will simply be equal to 10 sine 200, 10 sine 200. Okay, I'll plug in that, then I'll say Ry is equal to, when I do my calculation on my side, Ry, it is, oh sorry, not 200 but 0, not 200. Please take note of my, okay, so 0 there. Okay, so sine 0, you know it is 0, so this one will be 0 meters. So those are the what? Those are the components of the components of both R and X. So those are the component of R and A. Now what are we interested in? We are interested in knowing the components of vector B. Okay, so to know the component of vector B, this is an easy task. We'll start with components of vector B. Components of vector B. Components of vector B. Okay, so one thing that we have to understand from the question is that there was addition of vector B. So ax plus ay, ax plus bx, ax plus bx should give us Rx. And then we found that ax was negative 28.19078 plus C. Bx is equal to Rx, we found it to be 10. Okay, then this will go to the other side, so Bx will simply be equal to 10 plus 28.19078. so Bx will simply be equal to, when you add there, it will be 38.19078. so already I have found the x component, but I haven't found, okay, I've actually found the answer, because the question is saying find the components. Okay, so since I'm looking for the component, this is the first component which is correct there, and I put meters. Then the other one, it is the y component. I'll say ay plus by, it has to give me ry. And what we found was that ay was negative 10. Ay was negative 10.2602 I hope I can remember the value of ay. Yeah, I think this is the right one. Okay, 60, so 60 there, and then plus C by, which is simply equal to ry was 0, so by will simply be equal to 10.266060. so this was the value for what, for B1. After doing that, have been asked to, what else, direction. Okay, I've been asked to find the direction, which has to be the other part. So for me to look for direction, I am going to utilize that information. This is the reason why I was not I was not rounding off. So for the direction, what I'm going to do is I'm going to use the formula. What I'm going to do, I'm going to use the formula. So the formula is tan theta is equal to the y component modulus of the y component. In this case it is by over bx and then the modulus. So tan theta will simply be equal to the modulus of y, which is 10.26060 over the other one, which is 38.1907.8. okay, so this is the reason why I was not rounding off there. So when you plug in, when you divide those guys, it's going to give you tan theta is simply equal to 0.268666. Then theta will simply be equal to theta. You're going to say theta is simply equal to the tan inverse. So theta will simply be equal to the tan inverse of that particular number, which is 0.268666. After that, when you punch on your calculator, theta will simply be equal to 15 degrees. I'll round it off, but it's supposed to be 15.03799 degrees. So once I do that, ladies and gentlemen, this is not how you can write your answers. Look, it's not even looking neat. A lot of decimal places, it's simply showing that you don't know what you are doing. So your final answer needs to be written in terms of rounded off values. So you're going to say, therefore the components, okay, the components of B, of vector B, the components of vector B are that bx is simply equal to 38 meters. When you round off, it's 38 meters. I'm following the round off in the question. And then by is simply equal to 10 meters. By is simply equal to 10 meters. And then the direction, when you talk of the direction is simply equal to 15 degrees. So this is how the solution was. So this is how this question would have been easily found. So if I was to check using the xy coordinates, the xy coordinate or the Cartesian plane, this vector B is a vector which is somewhere there. And this vector is having the components, okay, it's having the two components. So the first component, it is along the x-axis, and this component is 38 meters. And then it's also having the y component, which looks to be short, and this is going like that, and this y component is 10 meters. and then vector B is simply here. So this is where vector B is. So ladies and gentlemen, this is how easily this question was. This is how easy this question was, and this concept has been explained using our lecture class part 1, part 2, and also the revision classes, which are of 3 types. So this was the answer. So I'll give you the assignment. I'll give you the assignment, which is find the magnitude of vector B. Find the magnitude of vector B. Find the magnitude of vector B. For those who are having a challenge with answering this assignment, go and watch our lecture class part 1 and part 2 on vectors. You can go as far as watching the videos. So ladies and gentlemen, this is what I had for you today. If there is any question, you are free to WhatsApp me on those numbers. But if you have a question right now, you are also free to ask right now. So please unmute yourself and ask questions.